Hey, Valentine's Day is coming up. It's right around the corner. Cozy Earth, you can currently get 41% off just by using our code at checkout. That offer disappears February 28th.
So take advantage of our 41% discount while it lasts, because after that, 21% isn't as good.
No, it's not as good, is it? You can find the Cozy Earth link in the show notes. Make sure you take advantage of our code before February 28th to get 41% off. InfoGo. Find the link in the show notes. Welcome to the podcast. I'm William.
And I'm Kat.
And that makes this a dash of info.
Little things you want to know.
So, Kat, I have a question for you. Have you ever heard of Benford's Law?
Didn't we just talk about it in one of our episodes?
Um, I'm not really sure. I learned this in college in economics, and we're going to get into how it really kind of works. And it's mind-blowing of how Benford's Law really works. So what if I told you that numbers themselves could act like detectives? That the first digit of a number could reveal something suspicious?
So, how is Benford's law used in fraud detection, elections, science, and even pandemics?
I think really, let's just start by diving into Benford's Law, and then it's an odd quirk of mathematics where the first digits of numbers aren't as random as you might think they are. Why don't you tell us about the basics of Benford's Law, and then we'll kind of dive into it a little bit more. What do you think?
Sounds good. Most people assume that if you look at the first digit of numbers, 1 through 9 should appear about the same amount of times, roughly 11% each. But in reality, 1 shows up about 30% of the time, 2 about 17%, and the frequency keeps dropping with 9 appearing less than 5% of the time. And this pattern shows up all over the place. Populations of countries, lots of countries start with smaller numbers, and stock prices and financial figures, street addresses, lengths of rivers, death counts, even physical constants in science.
Yeah, but why do these smaller digits dominate? Imagine a river growing from 1 mile to 10 miles. It spends more time in the 1 to 2 range than it does in the 9 to 10 range. And many things in nature or human activity grow exponentially, or they're measured across multiple scales, which makes smaller first digits a lot more common.
Here's a simple example. There are far more countries with populations starting with 1 million than 9 million. And stock prices? Well, a stock rising from $1 to $10 spends more days in prices starting with 1 than prices starting with 9.
So think about that. If you're investing and you see a stock price at 9, do you short sell? Do you buy? I mean, if it's at 1, it's a hold or a buy. If it's greater than that, it's kind of how it works. The mathematical core, we're really gonna simplify Benford's law here.
Yeah.
Benford's law follows a logarithmic curve. Numbers aren't equally likely. Smaller numbers dominate naturally. You don't need to calculate logs to see it. All you have to do is just know that numbers in real world data sets often start small and grow.
Fun fact, this law works for numbers in finance, science, geography, and even sports statistics. So anywhere numbers span several orders of magnitude.
Simon Newcomb in 1881. The story begins with Simon, a mathematician and astronomer. He noticed something strange while using logarithmic tables. The pages for numbers starting with 1, well, they were worn out, while pages with numbers starting with 9 barely showed any use. So Newcomb realized this wasn't random. People were using numbers starting with 1 way more often. So he published his observation, but it didn't get much attention at that time.
Introducing Frank Benford in 1938. He was testing thousands of numbers. He was a physicist and decided to put the idea to the test. He gathered over 20,000 numbers from all kinds of sources, river lengths, electricity bills, newspaper statistics, and more. His results confirmed Newcomb's observation. Smaller digits, especially one, dominated as first digits, and this pattern became known as Benford's law.
But it was ignored. Then it was rediscovered. So for decades, this law remained a curiosity, interesting but little practical use. But then in the late 20th century, with computers and massive data sets, well, Benford's law found real world applications in fraud detection, science, and auditing. And and suddenly, those worn pages from the 1880s weren't just a curiosity, they were a key to uncovering hidden patterns in numbers. So Benford tested everything from street addresses to atomic weights, proving this wasn't just a coincidence. It was a universal pattern in numbers spanning real world.
Hey, William, before we dive into real world applications, what do you say we take a break?
Absolutely. I've got that lemon water that's been calling my name.
Stay with us. We'll be right back.
William, I know how you love matcha tea with coconut milk.
Yeah, it's clean energy without a crash.
Then you'll love Mantra Matcha. They offer super premium ceremonial matcha and 6 superfood infused flavors made from the finest, youngest tea leaves for a naturally sweet, ultra smooth taste.
With each flavor, it's infused with powerful superfoods like cacao, ginger, and goji berries. And they also have those classic favorites like banana cacao, strawberry lemon, cinnamon goji berry, plus superfood berry, ginger beet, and rosehip dragon fruit. It's organic, non GMO, gluten free with 0 grams of sugar. You can enjoy it like me, or maybe hot or in a smoothie like Cat. Every purchase helps provide meals to kids through No Kid Hungry.
It's at mantramatcha.com. Get 15% off using our code INFOGO at checkout. Both links are in the show notes.
Hey, everybody, we want to tell you about strong coffee. Every morning it starts with a choice. You can settle for just coffee, or you can rise up with strong coffee. And it's the world's strongest cup of joe. Strong isn't just a drink, it's a movement. It stands for striving to reach our natural greatness.
It's born from one simple need to be better. They rebuilt coffee from the ground up, infusing organic coffee with collagen, protein, nootropics, and functional ingredients that fuel your body and sharpen your mind. No crash, no compromises, just clean energy, focus, and flavor that fires you up.
Yeah, so whether you're chasing kids, chasing goals, or chasing greatness, don't just do it with coffee, do it with strong coffee. And our listeners can save 20% off just by using our code INFOGO at checkout. Hey, if you're looking for your favorite band or sports team or TV show, check out Old Glory. They've been in operation since 1969 and they have over 300,000 items. They have from the Beatles all the way to Metallica, NFL, NBA. It really doesn't matter what you're looking for. They have tees, hoodies, hats, gifts, everything a true fan could ever want. And it's family owned and operated. They have fast shipping, free standard delivery on every order. And you know what? Our listeners get a 15% off at checkout using our code INFOGO. You can find the link in the show notes.
So now that we're back, we're going to dive into real world applications, forensic accounting, and fraud detection. Benford's Law is a favorite tool for auditors in the IRS. They check numbers in tax returns, financial statements, and corporate books. The idea here is if the first digits don't follow the expected pattern, something might be fishy. For example, Bernie Madoff's Ponzi scheme, analysts noticed unusual patterns in his financial reports that didn't match Benford's Law, which was a red flag among many others. It doesn't prove fraud on its own, but it points investigators where to look.
So, elections and voting data. Benford's Law has also been used to examine election results, looking for irregularities in vote counts. And this is important because it works well only for large, naturally distributed data sets, like total votes across many precincts. But misuse happens when people apply it to small data sets or numbers that naturally don't follow the law. And this can lead to false claims of fraud.
Researchers sometimes fabricate data, either intentionally or by mistake. Benford's law can help spot unnatural distributions in tables of numbers like lab measurements or survey results that suggest data might have been made up. Journals and institutions have used it as a tool to check scientific honesty.
You can use it to detect fake street addresses in government or delivery databases, or you can use it to spot fake social media followers. If an account numbers or metrics don't follow the expected pattern, they may be bots. And even COVID-19 case reports have been analyzed with Benford's law to, well, to flag potential anomalies in reported numbers.
The takeaway here is Benford's law is like a numerical lie detector. It doesn't catch everything, but when applied correctly, it can reveal hidden patterns, deception, or even errors across finance, politics, science, and even daily life.
But Benford's law is not a magic bullet, right? Because it's powerful, but not universal. It doesn't work well with small data sets. If you only have a few numbers, patterns will naturally look random. And it also fails for numbers with natural limits, like human height, shoe size, or grades in school. These numbers don't span multiple scales and are rarely follow the law.
And there's common misuse. Some high profile fraud discoveries have turned out to be false alarms because Benford's law was applied to the wrong kind of data. So, for example, trying to detect cheating in a small local election or a tiny survey dataset, results may look suspicious even when everything is honest.
It's a tool. It's not proof. So think of Benford's law like a magnifying glass, if you will. It highlights unusual patterns, but it cannot prove wrongdoing by itself. Investigators, scientists, and auditors always need other evidence before making their final conclusions or assessments about something.
It's kind of like a spidey sense for numbers. It tells you where to look, but you still need to dig deeper to find the story.
Yeah, I think Benford's law is useful, but you really got to apply it carefully, right? Because misusing it can lead to mistakes, while using it widely can uncover hidden truths in massive data sets. I think the key takeaway here is the data sets have to be massive. You can't use small data sets. Like you can't just use my neighborhood and come up with house numbers. You have to use the city or, larger data sets.
Why does it feel kind of spooky? Well, humans naturally expect numbers to be random. We assume 1 through 9 should appear about the same, when in reality, that defies expectation. And it feels eerie or even counterintuitive. But this is why Benford's law seems most magical. Numbers aren't behaving the way our brains think they should.
Yeah, so math meets mystery, the numerical fingerprint, if you will. Each data set has a kind of hidden signature, a pattern in its first digits, just like fingerprints, and they reveal identity. Numbers leave traces of truth, and that's why accountants, auditors, and scientists describe it as spooky or uncanny. A simple and invisible law can expose dishonesty or errors.
Now, let's kind of take a look at the bigger picture here. Benford's law reminds us that numbers aren't just abstract symbols, they reflect real world patterns, growth, and behavior. By paying attention to these subtle patterns, we can see what might otherwise remain hidden. It's a math meeting mystery. The ordinary becomes extraordinary when we look closely.
Yeah, numbers have stories to tell too. And Benford's law is a tool that lets us listen to them, turning something as dry as statistics into a detective for, a story for the real world.
I had never heard of Benford's law, but I mean, it makes sense.
It does make sense. And, I know we are a podcast. We're not a visual podcast, or we could really show you how this works. But I mean, if you stop and think about it, like the lower number, like you would think nine would show up as much as one, but in reality, it really doesn't.
Right.
And one shows up and it gradually goes down as you go away. And you can use this for all kind of things like YouTube downloads for different shows. It has so many uses that it's mind-boggling to think of how many uses it has.
Right.
Anyway, that's all I've got on this.
Me too. If you would like to support this podcast, tell a friend and help get the word out.
If you would like to help us support the show, you can do so at Patreon. That link is in the show notes.
And as always, William and I want to thank you for listening.
Whether you've been with us from day one or just tuned in, Kat and I say thank you.
Join the Facebook group at Info on the Go
Over there, you can share with us your show ideas.
or ask us a question.
Follow us wherever you get your podcast.
You could also send us a text using the link in the show notes or leave a review.
Leaving that review really does help others find us, but you can also email us directly at,
infoonthegopodcast@gmail.com.
and you can find that link in the show notes. Till next time.
Stay curious.